webinar, we're going to look at data from a ProSec GS9000 multi-channel system and looking at data collected in an urban area that has both tree roots and subsurface utilities. Our first step is to create a new project. We want to browse for a default directory, and then we want to give this project a name. I'm going to call this GS9000 Tree Root and Utilities Demo. We want to then find the equipment. This is a ProSec SegWide GS9000. We hit New Survey, which will create this project and all the subfolders needed. Our next step is to transfer data into the project. And then we can just hit the button Import Raw Data, radiogram data to the raw folder. Okay, that's completed, and we can see where our data is located here in the raw folder. Our next step is to create an information file, and we have to first set the number of channels. This particular system is an 11-channel configuration. The offset between channels is 7.5 centimeters, and it starts at minus 37.5 centimeters from the left. We want to click Help Set. Note that the channel naming starts with channel 1. Some systems may start with channel 0, and you'll have to manually adjust that. And here's the X offset. This particular equipment has no offset in Y. Then we want to highlight multi-channel general and make sure that this is on GPS here and say Import Create Info. And it has all channel 1, which makes info main, and channel 1 has the GPS naming convention, but with a different extension. But go to the Edit Info File menu. The first thing you want to do is hit the button called SegY Get TS, and that updates the time window and the samples per scan, and we'll also do that for info channels. We then want to create the GPS navigation by clicking ProSec to UTM, and this is not total station, so we say no. Okay, it's created the GPS, and here's the number of GPS listings for each swath. From there, we want to click on Info Channels. We hit SegY Get TS. It updates the time window and the sampling. And then here are the offsets. Then it's going to read the channel 1 navigation, and based on the offset, it's going to calculate its own track for each channel. We use this button here called Array to Nav. Okay, the navigation is finished, and it's now compiling all the GPS for each channel. It did give us an error that there are some files that have double GPS locations. It's not a major error. It just, whether you believe that there's locations where you can have the identical GPS, it just means the equipment isn't been moving in some areas, but we can leave that data in there. It's not critical to delete it. Okay, the GPS is finished. Our next step is to convert the data. Okay, with ProSec equipment, there is no DC offset in the data. We can actually look at one profile. We can actually apply a gain curve and look at the pulse signal to see if it's shifted away from the 0 line. And you see with ProSec, the data is actually all along the 0 line. There is no low frequency drift or low frequency noise. So when we convert this data, we'll use just regular batch gain and not batch gain minus wobble. I'm going to go back and reset the gain to 0 or 1, and then we'll hit just batch gain. Right now, the software is working in single thread mode, but we'll show you how to set it to multi-thread. What you normally want to do is put your number of logical cores that you have on your computer and then click on multi-thread. There's different areas where you can shut this on and off for convenience. If we do that and we go back and rerun this, It's now working in multi-thread mode and processing 16 radargrams at a time. Okay, the conversion is completed. Our next step we can do is we can actually look at the GPS track. Okay, there's the GPS tracks for this particular survey. After that, we need to apply the navigation, basically tag the GPS to those scans, and we hit the button here, GPS vector scan number. Okay, it's applied the navigation. After navigation, we want to do radargram editing. With the ProSec equipment, time zero is very close to the top and it almost doesn't vary between the equipment, but we're going to run it anyway. And we'll run this in multi-thread mode. And it found time zero at channel 8, or at sample 18, and the maximum is at 19. So it's almost no drift in any of the channels. It's now cutting the data and putting the edited data into the edit folder. And at the end of this operation, we'll have a new information file, which we'll call info channels edit. And we want to update to the new information file. Okay. After that, we want to go to the filter menu, put on the edit folder, and run a background filter on the data. Okay, the background filtering is done. And after the background filtering, we want to go to the Spectra plus Gain menu, and we want to hit the AGC, and then decide where we want to put our bandpass filtering. We could left and right click on the Spectra plot and say Help Set. And you can see that there's a little bit of noise on some channels. We can look at another channel and see if it exists in other channels. Yeah, we see it's there. And let's go further into the project. And some channels don't have any noise. Well, this is a very nice profile here. We can actually use this one to create our gain curve. But we hit AGC here. Then this gives us a little bit more gain in certain areas. Now you can see that some of that noise down at bottom is really this high frequency noise here. You can actually, if you want to get rid of it, you can right click here, hit Help Set, and then we can get rid of some of that high frequency noise. And maybe we can run this particular bandpass with this gain curve on the data. Once you do set a gain curve, you want to just check some other locations just to make sure that that gain curve is reasonable, because we're going to apply it across the entire data. Okay, that looks good. After that, we want to run bandpass. And please note we're running in multi-thread mode. You can actually shut it off if you want to actually see the bandpass in operation and see the graphic come up. Okay, bandpass filtering is completed. After we do bandpass filtering, we want to search for hyperbolas and do migration. We have to make this a lot larger, so I'm going to make the graphic maybe 4,000 pixels by 600 might work. Let's take a look at that. And that looks a lot better. Okay, we want to search for a hyperbola. We have a nice hyperbola there. We use our mouse to hold it down. You can use your mouse wheel or use your left mouse click to adjust the velocity there. And once we have a velocity, we can also adjust the aperture. And I'm going to use a small aperture here. And we want to test the migration. And there's the migrated data, and we can see a lot of the hyperbolas have been collapsed, and that's a pretty good migration. So the settings look good for the migration, and now we're going to run that in multi-thread mode using Kirchhoff migration. Okay, the migration is finished. After migration, we want to run a Hilbert transform on the data. Okay, the Hilbert transform is completed. From there, we could actually look at maybe one of the channels. We could look at the, for instance, shut off the radar folder. We could look at the filter folder, migrate, Hilbert, and bandpass. And you can also even put on the edit folder if you want as well. And we'll look at one profile by, we could say one row, and that'll make them side by side, for instance. If we do that, we can see the different processes side by side. Might be a little bit better to see it on rows. So we'll look at the first one in rows. And you can't see much here because we did a background filter on the raw data that didn't have any gain on it. And then down here we edited the data, took off time 0. From there we did background filter there, we did bandpass, we did migration, and then the Hilbert transform. Okay. If you wanted, you could also put several channels up there. If we want to make the first channel up there, we can look at on 3 of the channels, and you can compare the data like that as well. Okay, with that done, it's time now to compile to a 3D volume. We want to go over to the multi-channel menu here. We'll just compile the Hilbert folder first. We'll change the name of the 3D file. I'm just going to call it h.dat, and we put in a cell size. These channels are 7.5 centimeters apart. You can either make it inside it or outside it, whatever you want. I'm just going to use the original size. And then we'll want to hit the button called Help Set, and it will find the maximum number of grid cells in X and Y, and it's 2040. And in this particular data, we also see that the sample N is 701. But if we were looking down at that data, let's say, well, I don't want to compile all the data towards the bottom. You can actually come here into the focus button and say, I only need to go to like 350 or halfway down if I want. And then from there, I could just say, well, I don't need to have every sample in there. You could say, I only want to have half of it. You could actually come in here and say 175 or something and make a volume that might be get into a single volume. Now, if your volume gets too heavy, you'll have to use block gridding. Okay, well, let's see if this will compile to a single volume. And we'll put on the focus there. And here we go. Okay, this is going to compile to a single volume. The reason is it's so horizontal that the dimensions in the Y direction are very small. Okay, it's compiled the volume. I always recommend to interpolate into one cell. You either have an option just to interpolate into gaps where there's missing cells, or to interpolate every cell and even cells around edges or in between swaths. I like to use interpolate all, but not everyone does. And we'll let that run. Okay, that's completed. From there, we can go into OpenGL and look at our process data. And first of all, we might want to first get a Google Earth map. Let's do that. And we'll set this to zoom level of 19, and we'll make this just 1200 by 900, and we'll get a Google image. We'll always make sure that the Google image is It's horizontal, so we just say get corners. It's finished. And then we can put our Z data on top of that and scroll down. Let's change this to a grayscale. So I'm going to go down here and set it on 1. And I'll just recolorize the data right there for us. And let's just, if you want to make this so it's flat, we can make it flat there. And then we can scroll up and down our data set. And you can really see the utilities here. We can use the step minus button. You can see other utilities coming in. And there are tree roots in this data set as well. You can see areas like right here, tree roots that are coming into this below the street. I'm just going to reverse the color table here. I'm going to go on color table 2. And there we can see the tree roots a little bit better, and scroll up and down there. We also have the ability to do what's called overlay analysis. Let's say I wanted to stop at this level. I can hit the O button and then start hitting the step minus button, and it's adding deeper reflections onto the same map. So we can start to see utilities and trenches appear. And sometimes it could be, you can put on too much information, but now we're seeing everything down here, and you can see other small utilities. And this is probably a trench for even a larger utility going across the street as well. And this is filled in more over here, and we can actually see other utilities that are deeper in this location. So that's using overlay analysis. This data set was made with just the Hilbert transform. Let's go back and create the data with the migrate folder. So we could exit out of here, come back to the multi-channel menu. I can put now on the migrate folder and set this to M. And then let's create the migrated pulse volume. Okay, the migrated pulse volume is finished, and we also want to interpolate one cell into that, so I'm going to click the interpolate all. And note that it automatically appends the identifier int onto the data that's been interpolated. Okay, the migrated data is completed. We can go now back to OpenGL and put back on our map. And you can see the slices without going into the 2D mode if you don't want to. You can see the utilities in there. Let's say we want to put on an actual radargram. Here's one of the radargrams there. And then you could step through the radargrams if you wanted to. Plus. And we're putting on the different channels. You can also move this with your mouse and get things to move that way. You can actually store one of those to the screen, and then we can put on our Z plane, and then we can watch things go down there as well. And that might be, I'm going to stop it right there. And you can see we got some sort of utilities in that direction, and go up a little bit higher. And you can see different things there as well. There's the tree roots that are coming in this direction over here. And there are different levels, so they'll turn from white to black depending on what part of the pulse we're on and their depth. Anyway, that's basically the operations to do multi-channel with the GS9000. You have other options here in the display. You could actually come over here to the bitmap. We could put on a virtual 1, and then it'll make a hole. You could put back your Z plane, and then scroll down like this into the ground as well. Okay, this is a basic processing on how to look at GS9000 GPR Slice software.